Okay, so in this video, we will talk more about how to find p-value. Remember, we have met this several times in the previous note, and I'm saying, okay, we are going to discuss it in more details later on. So here is now that we are going to discuss more about this p-value. So p-value is found in the direction of the alternative hypothesis under each term. What does this mean? So let's sort it out in a visual aid. Remember when we introduced the hypothesis test, we said there is non-hypothesis and alternative hypothesis. So there are three different forms of alternative hypothesis: mu greater than mu zero, mu less than mu zero, and mu not equal to mu zero. Now, if your alternative hypothesis is a greater than sign, the p-value is the proportion of the null distribution that is greater than your test statistic. So the TS is short for test statistic. If our null distribution look like this, do you guys still remember what is null distribution? What is null distribution? That is the distribution of the test statistic assuming null hypothesis is true. And if we are trying to do a hypothesis test for the population mean here, it's going to be a t distribution with degrees of freedom equals to -1. Now here is the null distribution. We could calculate a test statistic based on the value that is given to us, right? So based on the sample, we could calculate our test statistic using this formula. Now suppose this is where your test statistic is. So the p-value is the proportion that is greater than this test statistic under this null distribution. So if your alternative hypothesis has a greater than sign, then this area under the curve to the right of the test statistic is your p-value. Similarly, if your alternative hypothesis is a less than sign, then, sorry for my drawing in, this note instead of in a pencil, it's really bad. So if your alternative hypothesis is a less than sign, then say if this is your test statistic that you calculated given the data you got from the sample, then the p-value is the proportion of the null distribution that is less than the test statistic. So here is the null distribution, here is the test statistic, and the area under the curve to the left of it is the p-value. Remember we said there are three forms of your alternative hypothesis. If it's a not equal sign, if your alternative hypothesis is a not equal to, then you have to consider the area under the curve for either to the left of this value or to the right of this value. So if this is not equal to, you need to you need to consider extreme in either direction. So if you are a little bit confused about what's going on here, let's take a look at an example. Now, suppose you are given that the H now is mu, N is 15, and the T test statistic you calculated from the sample data that's given to you is 1.58. Then we will consider the p-values that correspond to each alternative hypothesis. So the first case, when your alternative hypothesis is a greater than sign. Now we are going to draw a null distribution, and our test statistic 1.58. So here, when it's a greater than sign, the p-value is the proportion of the null distribution that is greater than this test statistic. So it's the area under the curve to the right of it. So the p-value is the probability t greater or equal to 1.58. So this is a t distribution. You guys know what's the degrees of freedom of this t distribution? It should be n minus 1, which is 14. So we need to look for the probability that the t is greater or equal to 1.58 when it's a t distribution with degrees of freedom equals to 14. There are two ways to find this value. I'm going to show it one more time in case that there are students who still are not quite sure how to find those values. But I will not show it anymore because you should know it already. So the first way to do it is to look at the t-table. So the t-table is here. Hold on. So let me move this. Here is the t-table. Okay. So this t-table, the first column is the degrees of freedom. The first line is the shaded area here to the right of your t-value. Now, you guys still remember what is our degrees of freedom? 14, right? And our value is 1.58. So there is no 1.58 here in this table. So we are not able to find the exact value of the alpha. But we could see these two values, 1.345 and 1.761 under degrees of freedom equals to 14. So this is 1.345. This 1.58 is in between this 1.345 and 1.761, which means your p-value should be in between the 0.10 and 0.05 here. So your p-value should be in between 0.10 and 0.05. If you want to know the exact value, so you could go to use the StatCrunch. So let me switch to StatCrunch. So here is the StatCrunch. If you go to Stat, Calculators, this is the t-distribution we are looking for. This t-distribution has a degrees of freedom equals 14. We are looking for the value that x is greater or equal to 1.58. This is 0.068. So yeah, you can see it is a value in between 0.05 and 0.10 as what we found out in the table. So the exact p-value is going to be 0.068. So this area is 0.068. That is our p-value. So this is when your alternative hypothesis is greater than 0. The p-value is the proportion of the null distribution that is greater than your test statistic. If your alternative hypothesis is a less than sign, then you are going to have your null distribution like this. This is your test statistic, 1.58. Then the p-value is the proportion of the null distribution that is less or equal to the test statistic, which means it's going to be this area, these area. So the p-value is probability that t is less or equal to 1.58. And this is going to be 0.932. You can get it, either using the StatCrunch again, or it's just a 1 minus 0.068 here, right? So this is when your alternative hypothesis is a less than sign. Your p-value is the proportion of the null distribution that is less or equal to the test statistic. So the last scenario is when your alternative hypothesis is not equal to sign. This is called two-sided test. Remember, these two are called one-sided test. So under two-sided test, you need to consider that it's either going to be greater or equal to 1.58, or is going to be less than the negative 1.58 because it's for both directions. So the p-value is the probability that t is greater or equal to 1.58 plus the probability t is less or equal to negative 1.58. Since the t-distribution is a symmetric distribution, so the area under the curve for both sides should be the same. So this is actually 2 times the one-sided p-value, right? So this would be 0.136. So let me write more here. So this area is 0.932. These two areas together is 0.136. So that is how you could find the p-value. Now, some of you may ask, this is t greater or equal to 1.58. This is t less or equal to 1.58. So they both have this equal sign. Is that a problem? No, that's not, because this t-distribution is a continuous distribution. If you guys still remember what we have talked about, the continuous distribution, the probability, do you guys still remember how to find the probability of a continuous distribution? That is from A to B, integration fx dx, right? So this is for continuous distribution. So the probability of x equals to any certain specific value is 0. So the probability t equals to 1.58 is 0. So it's okay that you include it in whichever side of the hypothesis. I'm sorry, how should I say it? It's okay you include it in when you try to find the p-value for the greater than sign, or the less than sign, or the not equal to sign. Okay, so this is about how you should find the p-value. So you can see that based on different alternative hypotheses, you will have different p-value. Thus, you will have different conclusion about your hypothesis, right? But your data is the same. It's the same data because you calculate the same test statistic. But just because your alternative hypothesis is different, you are going to have very different p-value. Thus, you are going to have different you are going to have different conclusions about your hypothesis test. So the important point here is this p-value, and thus the discussion and conclusion depend on which alternative hypothesis you chose. So you must choose your HA before you see the data. You can't, calculate it and then find out what your test statistic is. Then you try to see which p-value will be more favorable to you. Then you will decide, which alternative hypothesis I want to use. That's not right. You are playing the data. You should decide what your alternative hypothesis is before you see the data. Okay, so let's take a look at a discussion board question here. So here are several interpretations of the p-value. Which one is correct? And explain why. This is posted under your discussion board. I will stop the video here so that you could take some time to work on this problem, and I will talk about the solution in my next video.